Hey, welcome to another Math to Math Stoichiometry practice problem. This time it's problem number 3 of, again, practice number 1. So here's the question. When potassium iodine combines with bromine, it creates potassium bromide and liquid iodine. And the rest of it is, that's the skeleton equation. And then if 300 grams of bromine react, how much iodine will be created? So that's the problem that we have for our stoichiometry, and we have our skeleton equation. Potassium iodine combines with bromine. So potassium iodine, and again, if I look at this one right here, potassium iodine, I know that potassium's in column 1A, and it is a +1, and we will double check that. Iodine is in column 7A, which makes it a -1. Okay, since they canceled, we just go ahead and write it down, but let's double check and make sure that we have it that way. So we see in our thing here, we have potassium right here. It's in column 1A. Iodine is over here. Okay, or bromine, whatever we're looking for. So we see that. So potassium iodine. So it is 1, 1. So we're just going to go ahead and write down a single one so we know that it is potassium iodine. Okay. Now that is going to react again or combines with bromine. So we're going to put plus and we put bromine. Now the thing about bromine is we also, like anytime we have an element by itself, we have to see, is it diatomic? So let's go back to your periodic table, and we see our periodic table. Here are our diatomic elements right here: nitrogen, oxygen, fluorine, chlorine, bromine, iodine, and hydrogen over here. Again, it makes us 7. Bromine is one of them. So let's get back out of it, and we know that we're going to have to put that they're diatomic. When they react, they're going to create potassium iodide. So let's go back up to potassium iodide. Okay, so I have potassium. Again, as it is in the previous one, it's +1. And then bromine is also going to be a -1. So if we go back to periodic table, bromine's right here. That's in 7A. If I went down to page 13, it would say 1 because we know that they need 1 more electron. So it's a -1 in order to get to that octet. So again, because they're 1-to-1, they automatically cancel each other out. So we do not crisscross or flip-flop. So we're going to say that created potassium bromide, which is going to be KBr, plus iodine. Now you can't just leave it as that. We got to make sure that or is it diatomic? That's the thing. So is iodine diatomic? Again, I know what it is. It's in 7A. There's our 7 plus the hydrogen. So iodine is diatomic. So let's go ahead and put our diatomic there. So we know that it's diatomic. So now we have our unbalanced chemical equation. So now all we have to do is balance it. So we're going to balance our skeleton equation. So how are we going to do that? Again, I like to do that by go ahead and start on this side, and we're going to go ahead and put a K, and then we're going to put an I, and then we're going to put a BR. Now, how many do I have of each one? Well, I have 1 potassium, I have 1 iodine, but I have 2 bromine. I go to the other side. I have potassium, I have iodine, and I have bromine. So I have 1 potassium, I have 2 iodine right there because of the subscript, and we have 1 bromine. So I can't start with my potassium, but I can start with my iodine or my bromine. It doesn't matter which one we start with. So let's go ahead excuse me. Start first with our iodine. Since I have 2 on this side, I need 2 on this side, so I have to put a 2 in front. So that 2 in front tells me now that I have 2 iodines. So I'm going to put 2 iodines in there. Okay, and I get rid of this 1 by striking through. But I also change the number of potassium I have. So the number of potassium I have now is 2. Okay, so that changes this potassium on this side. So I have to make sure there's 2 on this side. So I have 1, so 1 times what equals 2. So we're going to put a 2 right there, which changes that to a 2, which I can get rid of this. And it also changes my bromine from 1 to 2. And by doing it, we'll cross this off. And by doing that, I got it balanced. So if I look at it, I have 2 potassium, 2 potassium. I have 2 iodine, and I have 2 iodine. I have 2 bromine right here, and I have 2 bromine with this 2 over there. So that's good. So my molar ratio is 2 to 1 to 2 to 1. Like looking at this, we'll make it bold and make it red. Okay, so I could put a 1 in there. I could put a 1 right here. That would be the same as what it looks like. Can I reduce this? No, I can't. So there's our molar ratio. Now, which is good. So that just means that we have our balanced chemical equation. So now after we balance it, we're going to start our stoichiometry. And we're going to start it down here by looking at start with the mass in the problem. So it says if we have 300 grams of bromine, if that reacts, how much iodine will be created? So we're going to start with our 300 grams of bromine, Br subscript 2. We have to put that in there because bromine by itself is diatomic, so we have to put that number in there just like we did up here. So if I have 300 of this, and I could just go over here and say, okay, if I have, 300 grams of this, how much of this over here, the question is how much iodine will be created. So we can tab that over to that. It says, well, we're looking for this. That's what we're looking for. Okay, sometimes I like to write this down just because visually it tells me where I'm going to go from what I'm going to go to. So we're going to start off with this. And again, one thing when we look at that 300 grams of bromine, remember that tells us how many significant figures. So we know that our answer has to be in, you got it, 4 significant figures. So after we get done with starting off with what we have in our problem, we're going to put our times in the line. And again, we're going to use our, molar mass of bromine. So we're going to figure out the molar mass of bromine. And we're going to put 1 mole of bromine on top. And what are we going to put on bottom? Well, on bottom, and we're going to go ahead and underline this. And if I scroll down, on bottom, we're going to put our grams of bromine. And again, let's make it lowercase because that's what we're looking at. Now we have to figure out what is the molar mass of 1 mole of bromine. Well, how we're going to do that is we're going to come over here and we're going to say our bromine, Br, and again, it's 2. Means I have 2 bromines, and that's going to multiply that by whatever the molar mass of 1 bromine is from our periodic table. So let's go to our periodic table. Find that bromine is 80. So we're going to multiply that 2 times 80. And I think we can figure that one out is a 160. So that's 160 grams. Okay. And so we're going to put that down right here as 160 grams. Now again, if I have something on top and bottom, we can get rid of it. So we're going to get rid of grams of bromine and grams of bromine. Now I have it in moles, but now I have to use that molar ratio. So now we're going to use our molar ratio. So that means we're going to go moles of bromine to moles of iodine. Now notice they're 1 to 1. So what are we going to put on top? Top is what we're looking for. So we're going to put 1 mole of iodine. And on bottom, we're going to put 1 mole of bromine. Now again, the reason we're putting this on bottom is because we need to get rid of this unit. So we're going to get rid of this unit because I have it on top and bottom. Get rid of that one also. And we're going to underline this. So now that we have that underlined, we can go ahead and put our, can't put our equal sign in it because we still got to convert it. We have from moles, now we got to go back to grams. We're going to use our molar mass, this time of iodine. So we're going to put our times in our line, and we're going to put 1 mole of bottom, so 1 mole of iodine weighs how much? So on the top, we're going to put grams of iodine. So let's go ahead and do that one. So we're going to figure that out right here. So I2 means that I have 2 iodines. Oops. I have 2 iodines times whatever the mass of 1 iodine is on our periodic table. So we'll go to our periodic table. Iodine is 127. So we're going to put 2 times 127. And what does that equal? Well, we know that it's 250 something. 258 is my guess. So let's go ahead and pull up our calculator. And let's just put 2 times 127 equals 154. Okay, or excuse me, 254. Let's double check that again. That's what we got. So 2 times 127 equals 154, and that's grams for my iodine. So that's what we're going to put right here. We're going to put 254 grams of iodine. Again, that's what's going to equal. So we're going to underline this. And now, what can I get rid of anything else? Well, yep, I can get rid of moles of iodine here. So we're going to so let me get rid of that. Get rid of this moles of iodine. Now the only thing I have left is grams of iodine. So we know that we're going to have grams of iodine. So now all I have to do in order to figure out what this is do our math. So let's pull back the calculator, and let's say, remember, we multiply by the top, divide by the bottom, but we can ignore the ones. So I'm going to have 300. We're going to divide that by 160. I don't have to multiply by 1, divide by 1, but then we're going to, once we get done with that, we're going to multiply that by 254. And that equals 476.25. 476.25. Okay, let's see that math again. So let's go ahead and do it again. 300 divided by 160 times 254 equals, and that's good. Now what is we have to do? We can highlight that. Okay, problem is we're not done with it. Why are we not done with it? Because we got to do our significant figures. So I'm going to unhighlight this, and we're going to put a line in. So where do we put the line in? First of all, we have to look back at the original problem. How many significant figures is that number? Well, it may look like there's only one because trailing zeros aren't significant, but they are significant if there's a decimal in the number. And in this case, there is a decimal in the number. So that means we have 4 significant figures. So we're going to count over 1, 2, 3, 4, put our line right there. That's where our line would go. The 5 says we do what? Were there any numbers after the 5? I don't think there were. That's what it was. So if I go back and click on this right here, that's what it was. So we're going to go just with that. This 5 says we have to look at the previous number, and we have to round that to an even number. Well, 2 is even, so we drop off the 5. So all we have to do is do that. And so we have 476.2 grams of iodine. That would be our final answer, and that's what we would highlight. There we go. There's our answer for that particular problem of if I had 300 grams of bromine, how many grams of iodine would be created in the scenario of potassium iodine combines with bromine to create potassium bromide and iodine. Again, this is a single replacement reaction, and that's how we get the answer. Make sure, show all your work, Cross everything out. Okay, as always, go Mohawks. Nelson out.